NVIDIA unveiled its latest advancements in artificial intelligence hardware at its annual GTC conference on Tuesday, introducing new chips designed to enhance AI model development and deployment. CEO Jensen Huang introduced the Blackwell Ultra, a next-generation chip family set to launch in the latter half of this year, alongside Vera Rubin, a forthcoming GPU architecture anticipated for release in 2026. The surge in NVIDIA sale, more than a six-fold increase since the debut of OpenAI's ChatGPT in late 2022, underscores the company's dominance in the AI hardware. NVIDIA's powerful GPUs have become the industry standard for AI model training, a critical component of artificial intelligence development. The unveiling of these new chips is being closely monitored by software developers and investors, particularly to assess whether the performance and efficiency improvements justify continuing investments from major cloud service providers like Microsoft, Google, and Amazon. These companies have collectively invested billions in AI-focused data centers powered by NVIDIA's technology. Quote, "This past year saw nearly the entire world engaged in AI. The computational demands and scaling laws of AI are not only robust, but accelerating at an extraordinary rate." The announcement also highlights NVIDIA's shift towards an annual release cycle for its chip families, a change from its previous biennial schedule before the AI boom. This strategic move positions NVIDIA to keep pace with the rapid evolution of AI computing. Taking place in San Jose, California, the GTC conference serves as a showcase of NVIDIA's market leadership, with an expected attendance of 25,000 people and participation from hundreds of companies, including Waymo, Microsoft, and Ford. The event underscores NVIDIA's expansive influence in the AI technology. General Motors also revealed plans to integrate NVIDIA's technology into next-generation vehicles. Continuing its tradition of naming chip architectures after prominent scientists, NVIDIA announced the successor to the Vera Rubin will be named after physicist Richard Feynman, with availability projected for 2028. In addition to AI chips, NVIDIA introduced new desktop and laptop systems featuring its processors. Among these are AI-centric machines such as the GGX Spark and the DGX Station, designed to run sophisticated AI models like Llama and DeepSeek. The company also unveiled updates to its networking hardware, essential for connecting vast arrays of GPUs, and a software suite called Dynamo to help users optimize performance. A significant component of NVIDIA's next-generation GPU system is its custom-designed CPU, Vera, based on the company's Olympus core. Unlike previous designs that relied on off-the-shelf ARM-based solutions, Vera represents NVIDIA's first custom-built CPU, promising twice the performance of last year's Grace Blackwell chips. When paired with the Rubin GPU, Vera is capable of delivering 50 petaflops of inference processing, more than doubling the 20 petaflops of NVIDIA's current Blackwell chips. Rubin will also support up to 288 gigabytes of high-speed memory, a crucial specification for AI developers. A notable change in NVIDIA's approach is its definition of a GPU. While the Blackwell GPU was composed of two separate chips functioning as one, Rubin introduces a shift in terminology. When multiple dies are combined to form a single chip, NVIDIA will now classify them as separate GPUs. In 2027, the company plans to release Rubin Next, which will integrate 4 dies into a single unit, effectively doubling Rubin's speed. The high-performance chip will be housed in NVIDIA's Vera Rubin NVL144 rack, an upgrade from its previous NVL72 design. The company also announced Blackwell Ultra, an enhanced version of its existing Blackwell chips. These will be capable of generating more tokens per second, allowing for greater AI model throughput and improving overall efficiency. NVIDIA asserts that cloud providers using Blackwell Ultra will be able to offer premium AI services with significantly higher revenue potential. The new chips are expected to generate up to 50 times the revenue of the Hopper generation, which debuted in 2023. Blackwell Ultra will be available in multiple configurations, including a version paired with an NVIDIA ARM CPU known as GB300 and a standalone GPU version called B300. Other configurations will feature 8 GPUs per server blade and a rack version equipped with 72 Blackwell chips. The rapid adoption of NVIDIA's hardware is evident, with the top 4 cloud providers deploying 3 times as many Blackwell chips as they did integrated Hopper chips. While the launch of China's DeepSeek R1 model in January initially raised concerns among NVIDIA investors, given its ability to function with fewer chips, NVIDIA has since embraced the software. The company plans to use DeepSeek's model for benchmarking its latest products. Despite concerns that more efficient AI models could reduce demand for NVIDIA's chip, Huang has maintained that developments like DeepSeek's ultimately reinforce the need for powerful computing solutions. He highlighted the emergence of, quote, agentic AI, a breakthrough in artificial intelligence that enables reasoning and problem solving, thereby increasing the demand for high-performance chips. Quote, in the past 2 to 3 years, AI has made a fundamental leap forward, Huang remarked. Agentic AI has the ability to reason and to determine how to solve problems more effectively. With the release of Blackwell Ultra and future iterations of its GPU technology, NVIDIA continues to solidify its role as a leader in AI infrastructure, ensuring its hardware remains at the forefront of the rapidly evolving AI landscape. If you enjoyed this update on NVIDIA's latest innovations, don't forget to like, share, and subscribe. Let us know in the comments what you think about these new AI chips and how they might shape the future of technology. Stay tuned for more updates. Thank you for dropping by.